Now the topic is quadratic probing. This is one of the collision resolution technique and it comes under open addressing. So if there is a collision, we try to store an element at some free space in a hash table, and the hash table, whatever the space is given, we try to utilize that same space. So in the previous video we saw linear probing. In linear probing there was a problem of clustering of element or primary clustering of element. That group of elements were forming a single block. So to avoid that, we have introduced quadratic probing. So let us learn about this one. So for explanation I have taken an example. Let us look at the example. I have keys in a key space. I have just taken 4 keys here and this is a hash table of size 10. I have taken keys that are less than half the size of the hash table. As I already said that loading factor should not be more than 0.5. So I have taken only 4 keys to explain. This is the hash function, modulus hash function. 10 is the size of the table, so this is 10. Then this is a modified hash function used for quadratic probing. So if you see, it looks similar only. H dash of x is h of x plus f of I mod 10. Yes, it is same. Here there is a difference. F of I is equals to I square. F of I is equals to I square. And I takes value 0, 1, 2, so on. So this is the difference between linear probing and quadratic probing. The next position is found with quadratic value, not a linear value. So it means in linear probing, if there is a collision, we were trying to insert an element at next free space, but here we will be giving a little gap. We will be storing at a little distant place. So how insertion is done? Let us look at this one. See, I have keys here. 23 mod 10, 3. So 23 is stored here only. Then 43 mod 10, this is also mapped here. So there is a collision. So for 43 I will calculate h of 43. This is h of 43 plus f of 0. So first time when it is 0, then this is 3 plus 0 mod 10. This is 3. But there is a collision. The next is 3 plus, this should be 1. So when it is 1 means this is 1 square, 1. So 1 mod 10, that is 4. So yes, there is a free space. So 43 is stored at next free space here. Now next 13 mod 10, 3 only, same place. So now this is also mapping there. Let us do it. So I will just change this one instead of writing once again 1. Now it is 0, right? So we get the index 3. There is a collision. Next time it is 1. So we get the index 4. That is again collision. Next we will do 3 plus, this will become 2. So 2 square is 4. Mod 10, that is 7. So yes, this 13 is stored at this 7, index 7. So you can see that element is stored with a little distance if there is a collision. So it means in this 3, first time we added 0, next time we added 1, next time we added 4, next time we'll be adding 9. So square, quadratic. So that's how this is quadratic probing. Now I have one more last element, 27, this will be mapped here, but there is a collision. So first with a 0 it will be a collision, this will be 7, and plus 0 it is collision, then 7 plus 1, 8, it is stored at 8. So 27 is stored at 8. That's all about quadratic probing. So I don't have to explain much in this one, it is same as linear probing, only the difference is we are getting the next location with a distance apart. That is not close or consecutive locations. Then about the analysis, there is a known formula, I will write down the formula. So here are the formulas for average successful search and average unsuccessful search. Just you have to accept these formulas and use them if required. That's all about quadratic probing.